Welcome back to Matt Explains Science. Today our lesson looks at the difference between mass and weight. So, firstly, we will clarify the difference between mass and weight and then look at a couple of examples. Because as you may or may not know, when we weigh ourselves on a set of scales, we are actually being shown our mass. Mass is the amount of matter of an object, which we have seen in a previous class. Weight, on the other hand, is the force that gravity exerts on matter. So in my case, I currently weigh 84 kilograms. But what I really should say is that I have a mass of 84 kilograms. My weight, however, depends on gravity. Okay, so on Earth, the force of gravity is 9.81 meters per second squared. To calculate our weight, we multiply our mass by the force of gravity. So if my mass is 84 kilograms and the gravity acting on me is 9.81 meters per second squared, then we can calculate my weight by multiplying the two together. This gives us a value of 824.04 kilogram meters per second squared, or more commonly referred to as newtons. I actually weigh 824 newtons with a mass of 84 kilograms. Now, if I were to stand on the surface of Mars, my weight changes due to there being less gravity. On Mars, I would still have a mass of 84 kilograms, but the force of gravity would only be 3.71 meters per second squared. So multiplying them together, we get 311.64 kilogram meters per second squared, or about 312 newtons. So let's look now at some mass conversions. In chemistry, it is not always practical to work with kilograms, as often we are working with the very small. Usually we need to convert to smaller units. This table shows the standard units of mass which we can use, starting with the kilogram and then working down through the gram, the milligram, the microgram, the nanogram and the picogram. We could go much smaller, of course. The mass of a single atom is in the order of 10 to the power of minus 24 grams. But for the purpose of showing how conversions work, we will keep it relatively simple. So an example, which of the following measurements is the heaviest? 0.03 grams, 300 milligrams, 3 times 10 to the power of minus 2 grams, 3 million nanograms, or 0.00003 kilograms. A good trick to find out which is the biggest is to convert them all to the same unit size. For this, let's convert all to grams. You could do this with any unit you like, but I'm going to stick to grams. So starting with 0.03 grams, which stays the same. Then 300 milligrams. We need to divide by 1,000 to convert grams, and that gives us 0.3 grams. 3 times 10 to the power minus 2 grams is just another way of writing 0.03 grams. 3 million nanograms. To convert to grams, we must divide by 1 billion. This gives us 0.003 grams. And finally, 0.00003 kilograms. Here we must multiply by 1000 to convert to grams. So we can see that actually 300 milligrams is the biggest value out of the 5. So when you have a group of numbers in different units, what you want to do is convert them first all to the same unit, so you can see easily which one is the biggest, and for ordering problems, to see which one is the smallest, etc. Okay, that's all for today. Just a quick lesson on the difference between mass and weight. Thanks again for watching, and please stay tuned for more content. Also, like and subscribe if you would like to help my channel out a little bit more. Thank you very much.